It took me 3.5 months to build a world-class deep learning model for my brain-computer interface startup. But I probably could have done it a lot faster if I didn't make a few mistakes. And I'm going to tell you those so you can do world-class things a lot faster than I did. Now, the first one, this one's obvious. Your data matters a lot. But what people miss out on is the way your model learns offline, meaning during the training process, and the way it used are different. So you need to make sure that the data you're training your model on translates. You can't have very optimistic or advantageous conditions during training time and have those conditions not be replicable during inference time. Because otherwise, while it may look good, 99% train accuracy, 99% val accuracy, at inference time, it's going to combust and not perform at all the way you want it. Now, the second thing that I think is super important that can speed up time is testing templates first. And what I mean by that is take super simple models and train on your data with that simple model just to make sure that your training script is right, your hyperparameters are right, and there's nothing wrong with your data set. That way you don't train what you think is going to be state of the art, and you can't figure out whether it's the model that's not performing, your training script that has issues, or your data that has issues. So being able to isolate those concerns and then figure out which one is the root cause is super, super advantageous. And it makes things a lot easier if you know already that your data is good and your training script is good. Now, the third thing, and this was super important to me because I'm self-taught, is you learn the theory about what architectures and what layers are good for capturing what kinds of features. But people don't really tell you how to correct or improve performance when your model isn't doing what you wanted it to do. And I think the simplest and easiest way to go about it is what we call comparing residuals, which means look at what the model is messing up. If it's a self-supervised task, compare your data. See what it's not capturing. Oh, it's not capturing long form data. Okay, maybe you need to capture long range dependencies better and adjust the kind of architecture you're using that way. Now, the last thing is keep things simple. A smaller model is a cheaper model, is a more efficient model, is one that's going to serve your purposes a lot better in the long term. I know there's all the hype about billion and trillion parameter models, but the thing that's going to do you the best is what works for your use case and doesn't mess up at all. So stay away from the hype. Try to get something that's simple, efficient, and clean. And best of luck building world class features.